Case study on architecture of Lotus Temple. Abstract: this paper is the case study of the architecture of Lotus Temple. In this paper the details about the Lotus Temple, general detail, and the architectural and structural study of Lotus Temple. How to construct Lotus Temple, which type of problem/challenges arises during construction, and the study of structural drawings. Keyword: Lotus Temple, project details, topography, concept, construction system, structural details, concrete, reinforcement, construction challenges. 1. Introduction. The Lotus Temple is due to its flower-like shape. Lotus Temple is also known by the Baha'i House of Worship/Baha'i Faith. The temple are well known for their architectural splendor, and the temple constructed in Delhi is a continuation of this rich tradition. This is prominent attraction in Delhi. It was completed in 1986 and serves as the mother temple of the India subcontinent. The temple structure like as the half-open lotus flower, afloat surrounded by its leaves. The temple is open to people of all cultures, faiths, and languages. It is the symbol of a united India. C:/users/Mohammed Sahil /desktop/Lotus Temple /Lotus_Temple_6-500x334.jpg. Fig. 1 Lotus Temple. C:/users/Mohammed Sahil /desktop/Lotus Temple /5.jpg. Fig. 2 Lotus Temple. C:/users/Mohammed Sahil /desktop/Lotus Temple /stringio.jpg. Fig. 3 Lotus Temple. 2. Details about location. The temple was constructed in the village of Bahapur, Kaukasi, in south of New Delhi and to the west of Connaught Place in Mandir Marg, a secluded area of bustling centre of India's capital. 3. Project details. S.No. Details. Details. 1. Architect. Faribert Sabah. 2. Structural designer. Flint and Nail. Flint and Nail Partnership of London were the consultants. 3. Designed in 1976. 4. Designed for, in year 200 year. 5. Built time period 1978 to 1986. 6. Constructed by ECC Construction, Group of Larsen and Toubro Limited were the contractors responsible for constructing the Lotus Temple. 7. Total site area 24 acres/105000 sqm. 8. Setting capacity 1,300 people. 9. Climate tropical with great variations in temperature. 10. Building type time of construction. Worship place. Fig. 4 Architect, Faribert Sabah. S.No. Details. Details. 1. Architect. Faribert Sabah. 2. Born on January 1, 1948, 72 years old. 3. Designation. Architect and Project Manager. 4. Education. He graduated from University of Tehran. 5. Project duration. Lotus Temple. 10 years. 4. Topography. The Lotus Temple site is sloping down naturally towards northeast direction. The level difference between NE and SW is about 10.0 m. There are natural contours as well as man-made contours in the form of grass slope. The temple is built on the highest area of the site. 5. Concept. The concept of the temple is external difference between the various temples. They all show meaningful and sacred symbols common to all Indians' religions. These are the symbols which have emerged in other countries and religions. One of these symbols is scared flower of the Indians, the lotus flower. Faribert Sabah developed the project for the temple inspired from the concept of flower which is symbolizes for purity, cleanliness in Hindu tradition. The plans for the temple took 2.5 years to complete. In the Lotus temple each component is repeated 9 times. 6. Construction system. The Lotus temple is constructed based on the arcaded construction system. Based on 9 radial grids. The Lotus temple, in which the structure of inner leaves enclose the interior dome in a canopy made of crisscrossing ribs and shells of intricate pattern. When views from inside, each layer of ribs and shells disappears as it rises, behind the next, lower layer. 7. Structural details. The complexity of the structure and the high level of labor necessary required a dynamic management with high grade of innovation. One of the essential means of achieving the fixed objective was to anticipate problems in advance and to resolve them using test and models. A. Part of structure. A. Basement. B. 3 groups of 9 shells springing from the podium. C. Double-layered interior dome. D. 9 arches. E. 9 ponds. F. Walkways. B. Ancillary building consisting of A. Information center. B. Library. C. Administrative building. D. Restrooms. C. Component of structure. Geometry. By the help of geometry problem, this typical structure design. The architect conceived the beautiful concept of the lotus, had to be converted/transfer into definable geometrical shapes such as spheres, cylinders, toroids, and cones. The structure shapes were translated into equations, which were then used as a basis for structural analysis and engineering drawings. The resultant geometry of structure was so complex. The designers took over 2.5 years to complete the detailed drawings of the Lotus temple. Complex geometry in simple terms described below, such as A. Entrance leaves and outer leaves. The surfaces created by the shell on each side of the entranceways and the outer leaves are formed by spheres of different radii, with their centers located at different points of the interior of the building. There is a group of spheres for the leaves of the entrance, some of which define the interior surfaces and others which define the exterior surfaces of the shells. The diameters of the spheres have been fixed to satisfy the structural consideration of the varying thicknesses of the petals. C:\users\Mohammed Sahil /desktop/ Lotus Temple /104 Lotus Temple Information Center.jpg. For the outer leaves, another group of spheres define the interior and exterior surfaces of the shells, but in this case the thickness of the shell is uniform, 1.33 m thick toward the lower part and 2.55 m toward the upper extreme. The structure of outer leaf in the entrance zone to the temple is 15.4 m wide and rises 22.5 m above the podium. The structure of the interior is 18.2 m wide in the entrance area and rises 7.8 m above the level of the podium. B. The inner leaves. The structure of the inner leaf, comprising a cusp, ridge, and a reentrant, valley. The structure of the inner leaves rise to an elevation of 34.3 m above the inner podium. In the Lotus temple, at the lowest level each shell has a maximum width of 14 m. It is uniformly 200 mm thick. C. The arch. The arches play important role in Lotus temple because almost the entire structural load of the temple's interior space is supported by 9 arches which spread out around the central hall, located at angular intervals of 40 degrees. The Lotus temple forms of these arches are created by flat, conical, and cylindrical surfaces. In the Lotus temple, the intersection of these surfaces presents interesting contours and considerably improves the beauty of the arches. The 9 arches bear almost the entire load of superstructure beams were due-edged, leaving the central hub supported. D. The interior dome. In the interior dome structure 3 ribs spring from the crown of each arch. Up to certain height, the space between the ribs is covered by 2 layers of 60 mm thick shells. In the interior dome structure other radial ribs rise from each of these intersections and all meet at the center of the dome. While the central one, the dome rib, rises radially towards the central hub, the other 2, the base ribs, move away from the central rib and intersect with similar base ribs of adjacent arches, thus forming an intricate pattern. Fig. 6 Model of the temple at the Information Center. c:/users/Mohammed Sahil /desktop/Lotus Temple /6 copy.jpg. Fig. 7 section showing interior dome. c:/users/Mohammed Sahil /desktop/Lotus Temple /Lotus Temple Delhi 5-638.jpg. Fig. 8 height of petal. Fig. 9 section through entrance leaf and interior dome. c:/users/Mohammed Sahil /desktop/Lotus Temple /1311B0A96760-3E269327116 BCBF53483B.jpg. Fig. 10. Lotus Temple structure detail. Analysis and design of structural component. The Lotus Temple structure spherical surfaces for the entrance and outer leaves. Arch sockets have a parabolic cone shape. Spheres, cylinders, toroids and cone for inner leaves. 9 interesting spheres from interior dome. Final geometrically converted shapes were so complex that it took the designer over 2.5 years to complete the detailed drawings of the temple. In situ reinforcement concrete construction. Gunite. Interior dome is 28 m is height and 34 m in diameter. The structure of inner leaves are of 200 mm thick and of 33.6 m in height. The structure of outer leaves are of 135 mm from their cusps to the line of glazing, beyond which they thicken to 250 mm and of 22.5 m in height. The structure of entrance leaves are of 150 mm at center to 300 mm thick at their edges and of 7.8 m in height. The structure of shells within the interior dome, 60 mm thick. Lotus Temple designed for A. Dead load. B. Live load. C. Wind load. Wind tunnel test in Aeronautical Engineering Department at Imperial College, London. D. Earthquake load. Lotus Temple is designed by A. Tubular steel glazing frames. B. Finite element analysis. C. Equivalent grillage models for shells in the computer program. D. Quadrilateral element. 8. Materials. The inner surface of all the shells have a uniform, bush-hammered, exposed concrete surface with architectural patterns. For the inner leaves, these patterns were formed out of radial and vertical planes intersecting the surface of torus. For the outer and entrance leaves, and the interior dome, the patterns were formed out of longitudes and latitudes of sphere. The Lotus Temple structure formwork was designed in a manner that timber joists support the panel instead of the regular pattern of the structural steel supporting members of the structural steel supporting members of the space frame. c:/users/Mohammed Sahil /desktop/Lotus Temple /Lotus_Temple_const_6.jpg. In the Lotus Temple full-scale mock-ups of the bottom surface of each of the shells were first made at ground level and the architectural patterns marked on this surface. 9. Concrete. In the Lotus Temple all the ribs and shells up to radial beam level are in white concrete. To avoid crazing and shrinkage cracks in Lotus Temple structure, a mix of M30 grade white concrete was designed. The entire quantity of white cement for Lotus Temple was therefore imported from Korea. Specially graded dolomite aggregates were procured from Alwar mines near Delhi and white silica sand from Jaipur. Water/cement ratio, 0.43. Slump achieved was in the range of 70 to 100 mm. Bush-hammered finish for interior dome, inner and outer leaves. Concrete was drum mix on site. 3 inner leaves at 120 degrees spacing, were concreted at a time, in only 2 lifts from their bases to the level of the star beams above. Outer and entrance leaves were concreted in a continuous operation one at a time, using the removable outer shutter panels for access for concrete and vibrators to avoid cold joints. Concreting time for an outer leaf of Lotus Temple was of the order of 48 hours. Ice melt water was used in the mix to take care of the hot weather in Delhi to cool the concrete, that brought down temperature of concrete from 40 degrees Celsius to 25 degrees Celsius. Systems of horizontal sprinkler pipes were used in curing. 10. Reinforcement. The structure of Lotus temple petals were reinforced with 300 tons of galvanized bar to avoid the risk of rust staining and cracking and to maintain the pristine appearance of this monumental structure. The Lotus temple structure, in which the reinforcement used in the white concrete shells as well as the binding wires was entirely galvanized so as to prevent the long-term effect of rusting of reinforcement on the white concrete. Since galvanized reinforcement for concrete is seldom used in this country, several tests were carried out to ensure that the mechanical properties of reinforcement did not become adversely affected due to galvanizing. In the Lotus temple structure, to avoid the impression of cover blocks on the exposed surface of the shells, the inner layer of reinforcement was held in position by special steel spacers supported from the outer formwork. 11. Construction sequence. In the starting of construction, basement and the interior podium were first built. From there, to raise the arches and shells, the structure was divided in parts, bearing in mind that when the formwork was removed, the constructed part would support itself until the next part was complete. The structure was divided in the following way: arches, inner leaves, radial beam and central axis, interior dome, axis and outer leaves, staging and formworks. 12. Construction challenges. Excavation were undertaken by Al-Walaya Construction Company. Primary support to the formwork for the shells, dome, arches, were designed by the contractor and constructed of welded steel. Plywood form. Purlins. The Lotus temple structure related forms and their supports for the all shells were designed withstand pressure from continuous concreting, and the outer forms were placed as concreting proceeded. The structure of 3 inner leaves were concreted at a time, generally in only 2 lifts. 13. Marble cladding. Lotus temple, in which the shells and arches are clad in white Greek marble panels, performed in Italy to the surface profile and to patterns related to the geometry by Marmi Vicentini S.P.A Company. The Lotus temple, in which the panels are fixed by means of stainless steel brackets secured by bolts in holes drilled after concreting, and the joints were filled with molded rubber cordon and silicon sealant was applied over it. Floor finishes were also of white marble. Balustrades, stairs were precast. Stones used for stairs were made of red sandstone. Complete construction of the structure was completed in the year 1986. 14. Conclusion. Lighting and natural ventilation used in the building. The structure of Lotus temple is very typical and complex. High standard of quality demanded at the time of construction. The work is very innovative, so the skills worker and labor used at the time of construction. The complete structure is both architectural and engineering point of view wonderful and marvel. 15. Acknowledgement. The case study paper right on the topic of case study of architecture structure of Lotus temple is suggested by E.R. Prafull Kothari, Assistant Professor. E.R. Prafull Kothari sir gave the idea about how to write the case study paper, what include in case study paper, and help him to complete the paper. Suggest the internet site by the help of sir this case study paper complete. I would like to express my gratitude to E.R. Prafull Kothari sir, who gave me the possibility to complete this paper and encouraged me to go ahead with this paper. So, Mr. Prafull Kothari sir is acknowledged for the support, suggestion, and help.